Hello calculus students, we are going now to talk about absolute versus conditional convergence. And in a nutshell, absolute convergence means that the series of all the positive terms will converge, and the alternating series, the ones with the negative and positive terms, so this is mixed positive and negative terms, will also converge. So if the positive terms converges and the mixed negative and positive terms converge, then the series is considered absolutely convergent. The other type of convergence that we talk about is called conditional convergence, which means that the series that has mixed positive and negative terms will converge, but the ones that has all positive terms will diverge. Okay? So I should give you an example of absolute and conditional convergence. Okay? And we've seen two examples of this before. So absolute convergence. So if you consider this series, this is the geometric series, and there's lots of geometric series that we can choose from. If you look at these two series, okay, this series here will alternate between negative half plus 1/4 minus 1/8. Okay. This series here is just 1/2 plus 1/4 plus 1/8, and both of them converges. So this is what is meant by absolute convergence. That you have two series that are almost the same. One of them has all the positive terms, and one of them has alternating positive and negative terms, and they both converge. So in this case, this is called absolute convergence. Now consider conditional convergence, and we've seen examples of this as well. So if you consider this series, n equals 1 to infinity of 1 over n, okay, and this is nothing more than the harmonic series. This we know is divergent. Okay, so this series is all terms are positive, okay, is divergent, but its alternating series we talked about before in the last video is convergent. Okay, so this is a case of conditional convergence, that the alternating series is convergent, but the series with all of the positive terms is divergent. Okay? And the harmonic series is a good example of that. Okay? So you should think about these two questions on your own before you continue playing with this video. Does absolute convergence imply conditional convergence? And does conditional convergence imply absolute convergence? Well, you can kind of see from the definition that if something is absolutely convergent, that both of these versions of the series will converge. And if it's conditional, that means only one of the two series may converge. Okay? So let's name this question 1, and let's just think about it in this sense. If you have two series that are identical, and one of them has all positive terms, and then you look at the other series that is the exact same series, but terms may be positive or negative, well, just ask yourself, which is larger? And clearly it's the one with all the positive terms. So if this one converges, then this one has to converge as well. Right? But the reverse is not true. If the series that's smaller converges, it doesn't say anything about the other series. So the answer to number 1, does absolute convergence imply conditional? Of course, yes it does. Does conditional convergence imply absolute convergence? No. Okay, they may be. This may happen sometimes, but it's not enough to. It doesn't happen all of the time. So there are cases where a series could converge conditionally, but not converge absolutely. Okay, so conditional just means that the series that has the mixture of positive and negative values will converge, and absolute convergence means that the series that has the negative and positive values will converge, and the series that has all positive values will also converge. Okay, because the series with the bigger values, with the absolute positive values here, will always be larger than the other series. So the answer number 1 is yes. The answer, we'll call this question number 2, is no. Well, there you have students, some notes here for us and some examples on alternating series and absolute convergence. Thank you for watching. Have a wonderful day.